All right, so if you're getting to this unit and you just finished factoring, you might want to go back a little bit and brush up on your quadratic relations unit. So this is quadratic relations is the unit that is most similar to this unit because we're going to use a lot of the same details and information. Now that being said, factoring is a key part to this unit as well. This is why we cover both of those units just before we get into this. So let's get into a little bit of prerequisite knowledge first to make sure that we remember all that stuff from the factoring as well as the quadratic relations. So graphing, parabolas, and key characteristics. This is kind of like our go-to start point. All right, let's use blue for this video here. All right, so quadratic relations in the form y is equal to a times x minus h all squared plus k. We know that that's the vertex form. And the reason why we know it's the vertex form is that we can actually pull the vertex directly from this form with the value of hk. Our vertex is really just hk. So that's pretty useful information. We can get that just by looking at the quadratic relation itself. So as well, we also learned this form as well, y is equal to a times x minus r times x minus s. This is what we called factored form. And you can see that it's factored form just by looking at it. We can see that there's factored terms in there. So this is factored form. Now, both of these things can be used to graph parabolas. When we have factored form, this gives us the x-intercept. So there's 2 points right there. We just need to figure out where our vertex is, and we're good to go. If we have the vertex form, we can start with that. We just need a little bit of information. Maybe we use the mapping pattern. Maybe we use a step pattern. Sorry, mapping notation or the step pattern. Either way, we can graph from either of these circumstances. So key characteristics can be found such as I said, the vertex, which is located at hk. The axis of symmetry, we know that that is always x is equal to h, whatever the h component of your vertex is, so the horizontal component. And of course, we can also get the x-intercepts from our factored form, and this is really just the r and the s values. And this tells us exactly where it's hitting the x-axis. Great. There we go. All right. So let's put this to the test and try and remind ourselves how all this stuff works. So given the quadratic relation, y is equal to negative bracket x plus 1 all squared plus 4. Now looking at this information, first thing you're going to want to do is look at it and try and pull out all the key values from here, our a, our h, and our k. Now the a is always the value that's in front of the squared value. Now this whole set of brackets is squared, so it's in this case, it's just the negative 1. Now we want to look at h and k. So what is h? H is always the value inside the brackets. So if we see x plus 1, remember the relation is x minus h. So our h value is always going to have the opposite sign of what we see inside of here. So in this case, this is a 1, so our h value is negative 1. Our k is always the value that's going to be added to the squared term on the outside. So in this case, k is just equal to 4. Now, that information alone tells us so much about our curve. So let's start filling out some data. We're going to make a little bit of a table of values over here. We're going to use the following values. X is equal to negative 3, negative 2, negative 1, 0, and 1. And we're going to substitute all those values into our quadratic relation. This will tell us the corresponding y values for each of those x components. Okay. So when I substitute negative 3 in here for x, that's negative 3 plus 1. So that gives me negative 2. I'm going to square that. Negative 2 squared is 4. Now I have to apply the negative sign on the outside. So I'm negative 4. Negative 4 plus 4, that just gives me 0. Okay. Ooh, that's a y value of 0. That tells me that that's an x-intercept because we know that anything with a y of 0 is on the x-axis. So that's an x-intercept. That's good to know. Negative 2. Negative 2 plus 1, that's going to give me negative 1. Squared that, that's 1. 1 times negative 1 is negative 1. Negative 1 plus 4 is going to give me 3. Now, once you keep going through this, you're going to find that you're going to end up with a value of 4, 3, and another value of 0. Now, we can look at this and we can see exactly where the curve is actually going to flip, where the axis of symmetry is. We can see that it's going to be right at the negative 1 because the two y values after it are surrounding it, and they're both below that y value. So this we can see that is going to be a maximum. We know it's a maximum because the a value is negative, which means it's opening downward. All that information just from looking at the graph, or just from looking at the quadratic relation. So where's our vertex? Our vertex is located at HK, right there. Negative 1, 4. We can see that right up here, our HK. So we can write that down, negative 1 and 4. We know that the direction of opening is based on the a term. A is less than 1, sorry, less than 0. It's a negative value. So that means that it is opening down. Okay, that's because a is less than 0. The axis of symmetry is always x is equal to h. H is negative 1, so our axis of symmetry is x is equal to negative 1. X-intercepts and y-intercepts. Now I can find these in a couple ways. I can find the x-intercept by simply looking at my y values. The x-intercepts means it touches the x-axis. What is the value of y on the x-axis? It's always 0. So whichever ones of these components have a y value of 0, those are going to be my x-intercepts. So I can see the bottom one down here, that's an x-intercept, and the one at the top, that's also an x-intercept. So I have an x-intercept of negative 3, 0. And I have one of, let me just put my brackets around there, and another one of 1, 0, which is the one down at the bottom here, 1, 0. So I know that it's going to hit the x-axis at both of those locations. So let's put it down there. We got our draw our little negative 3 there, and we draw our 1. Okay, now what about our y-intercept? Y-intercept is where think about where the y is. The y is the vertical axis. So that means that it's touching that axis. So in order for that to be true, that means the x value must be 0. So if I look over here on the left-hand side, the only one that has an x of 0 is right here, 0, 3. So our y-intercept is this one. So we see that that's located at 0, 3. Now we have all this information. We have our vertex. We can write that in, negative 1, 4, negative 1 all the way up here at 4. We also have our y-intercept, which is at 0, 3, right there. So because we have our axis of symmetry, we know our axis of symmetry goes straight down past the vertex, straight through here. Anything on the right side has to have a mirrored value on the left. So one x component away from the vertex, we see that it dropped by 1. So we know that there's another point right here. We have all this information. Now we just need to connect the dots. We draw our line. Pop, 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 pop. All the way up and down. Don't forget your arrows. We've already labeled our axes, so we just need to write in our equation now. Y is equal to negative x plus 1 all squared plus 4. Great. So that's all we're looking for in that regard. Lots of information. Let's do it again, but now we're going to do it in factored form. So instead of the vertex form, we have factored form. So let's see what kind of information we can pull out of here. So we know that the a value is right here. This is our a. So our a is equal to 2. Our r value is right here. And we can see that r is also equal to 2. Remember the formula. The formula is x minus r. So our sign here, our r in this case is going to be a 2. Just like our h up in our equation up in here is always the opposite sign of what's inside the brackets, the r and the s are the same thing. It's always going to be the opposite of the sign you see there. So our r is got a value of 2, and that means our s, which is this one right here, it has a value of negative 2. Okay, so we've got all the key information that we need. Let's go fill out our table of values first. So we have our negative 2. We're going to substitute that in for all of the x components. So negative 2 minus 2, that gives us negative 4. Over in the next one, we have negative 2 plus 2. Well, negative 2 plus 2 is 0. Uh-oh. 0 times anything. All of these are multiplications. 0 times anything is just going to give us 0. So we're done with that one. Great. Oh, a y value of 0. That tells me an x-intercept. Negative 1. So negative 1 minus 2, that's negative 3. Negative 1 plus 2, that's 1. So we have 1 times -3, that's -3, times 2 is -6. Now, when you keep following this pattern, you're going to end up with -6, -8, -6, and 0. We can clearly see that there's our turnaround point because the values before and after it are mirrored, and this one is the one in between. Great. But let's keep going on here. So let's draw in everything. So instead of filling out the table, let's draw it in, and then let's get all this information from looking at the actual graph itself this time. So we have -2, 0. We have -1, -1 right here. We have 0. Oh, sorry, that wasn't -1, -6. It should be -1, -6. Oops, there we go. Let's try it again. -1, -6, all the way down here. And then we have 0, -8 right here. And then 1, -6. Oh, there's our turnaround point. And 2, 0. So we connect the dots. And all the way back up. Oh, this is a pretty terrible parabola. Okay. But we can see everything. We can label it. Y is equal to 2 times x minus 2 times x plus 2. Okay. And we label our axes, x and y. We got everything we need on this curve. Do a better job of drawing your parabola than I did, please. It's very difficult on this drawing tablet. Ironically, you would think it'd be easier on a drawing tablet, but no. Anyways, so where's our vertex? We can just look at the graph. We can see that it's down here at 0, -8. We could also see that in the table of values as well, but it is what it is. We cannot pull it directly from the equation this time, not directly anyway. Although we could do a little bit of math to figure it out. So what direction is it opening? Well, it's opening up. We can see that in the graph. We can also look at the a value. The a value is greater than 0. So it's opening up. Axis of symmetry. Where does it turn around? Right at the value of x is equal to 0. We can see that by looking at the vertex. X is equal to h. H is 0. So x equals 0. The x-intercepts, where is it touching the x-axis? It's touching it at -2 and +2. So we have the values -2, 0, and we have +2, 0. Y-intercept, where is it touching the y-axis? Well, that's actually where the vertex is. So that makes life a lot easier. Now, this is a parabola, so it's only going to touch the y-axis at one location, ever. All right, so in this case, we have 0, -8. And that's all the information we need. As I said before, if we couldn't actually see the graph, how would we actually calculate the vertex using just this information? Well, in order to calculate the vertex, we need to find the midpoint of our two x-intercepts. Remember, to find the midpoint of our two x-intercepts, our midpoint of any 2 points is always the first point plus the second point. So in this case, it's going to be r plus s divided by 2. Well, r is 2, and s is -2. Well, 2 plus -2 is 0. 0 divided by 2 is still 0. That tells me the x component of our vertex is 0. Now, I would need the y component. How do I find the y component? To do that, I would just sub the one value I know, x, into our relation. And what you'd end up with is the only thing left would be the y. So I'd have y is equal to 2 times 0 minus 2 times 0 plus 2. If we look at that, that's the same thing as 2 times -2 times 2, which is going to give us -8. So now I know the x component and the y component, 0, -8. So it is still possible to calculate the vertex even if we don't have the graph to look at. Okay, let's dig a little deeper. Let's kind of summarize things a little bit for us here. All right, so a quadratic in factored form can be used to find the x-intercepts r and s. Of course we can. We just have to look at the values inside the brackets. Remember, it's always going to be the opposite sign that's beside the number. Then the vertex and other key characteristics can be found in order to graph the parabola, which we just demonstrated here. If you're given a quadratic relation in standard form, we haven't talked about that yet today. standard form. Standard form is y is equal to ax squared plus bx plus c. That's the one we're used to. All you have to do is factor the standard form, and if you do, you're going to end up into factored form. That's how you convert. You can go from standard form to factored form simply by factoring the relation. Okay, factor the relation. If you set y is equal to 0 and solve each factor, what we can do is we can find the x-intercepts. So we're going to set y is equal to 0 to solve and find each factor. And we're going to take each factor that's in the factored form, and that means we're going to set each one of those to 0. Now that seems a little confusing for this second. So let me kind of give you an example. If we have this relation up here, y is equal to 2 times x minus 2 times x plus 2. What I'm saying here is if you set y is equal to 0, right? Where is y is equal to 0? That's the x-axis. Oh, that's what we're trying to find. We can find the x-intercepts, all the points where it touches the x-axis, which is when y is equal to 0. So if we set y is equal to 0 and just solve for x, we're good. All right, so let's put all this stuff in here. X minus 2 times x plus 2. Now what this table is showing us here is it's saying because this is 0, we can simply divide both sides by this a value and get rid of it. And then it would just disappear. If we divide both sides by 2, this 2 goes away, and 0 divided by 2 is still 0. So it's just 0 is equal to x minus 2 times x plus 2. But we don't even really need to do that because we know we can. So what this final step here is saying this. Set y equal to 0 to solve by setting each factor equal to 0. So I'm going to take the first factor, x minus 2. I'm going to set that equal to 0. And just solve for x. Bring the 2 over to the other side. We have x is equal to 2. We can do the same thing on the other side. So let's say we have x plus 2 equal to 0. And then you'd say, all right, well, I bring the 2 over to the other side. That means x is equal to negative 2. Now you're looking at this and you're like, I don't need to do that step. I can just look at the brackets, sir, and I can see that my two factors, my two x-intercepts are going to be 2 and negative 2. Why did you show me this ridiculous, complicated way? Because you're not always going to get nice factors like this. You might end up with something along these lines. Maybe you get y is equal to, let's say, 2x plus 3, and y is equal to 4x plus, 5. What I'm saying here is set y equal to 0. And over here, we got 4x plus 5. Now set each one of these equal to 0. 2x plus 3 equal to 0. Well, we bring the 3 over to the other side, so we have 2x is equal to negative 3. Now we got to get rid of that 2, so we divide both sides by 2. And we get x is equal to negative 3 over 2. Oh, we just found an x-intercept, right? We just found an x-intercept at negative 3 over 2. It's not always going to be a nice perfect number like you see here. Sometimes it's going to be a little bit more complicated. Similarly speaking, we can go to the other side and we'd end up with negative 5 over 4 on this one. Okay? So this is going to come up during the rest of this unit. We're not always going to have nice perfect numbers. So we have to know how to deal with this. So this is how we can actually solve for those x-intercepts just by looking at the quadratic relation itself. All right, let's keep moving on. Alrighty. So in this question, remember it said that if we are giving something in standard form, we can factor it, and then we can put it into factored form. That's what we're going to do now. Just get my notes where I want them here. There we go. So factor the relation, then find the x-intercepts, the coordinates of the vertex, and graph the parabola. So we got lots to do here. So the first thing is we need to factor this. We got to look at this and say, well, what kind of factoring is it? This is a simple trinomial. So that means we need to find two numbers that add to the middle term. So add to 8 and multiply to the final, in this case, to 7. Well, what are all my multiples of 7? 1 and 7? Oh, I can get to 8 from 1 and 7. So 1 and 7. So what should the signs be? Well, I have a positive here, so that tells me that the signs are going to be the same. I have a negative here, that tells me that they're both going to be negative. Boom, -1 and -7. Okay, now we just got to fill it out. Y is equal to x minus 1 and x minus 7. So we have it in factored form now. So now what we want to do is we're going to find the x-intercepts. So I'm going to write this out. We're going to find the x-intercepts. Okay, in order to do that, we need to set y equal to 0, because that's when we get the x-intercepts, when the value is actually on the x-axis. So we're going to set y is equal to 0. All right, so now we have 0 is equal to x minus 1 times x minus 7. Okay, what's the next step? Now we need to solve each factor to find the x-intercepts. Now solve each factor to find the x-intercepts. Okay, so now it means for each one I'm going to set each factor to 0. So I have x minus 1 is equal to 0. That's just going to be x is equal to 1. There's my first x-intercept. And then I have x minus 7 is equal to 0. That's just going to be x is equal to exactly 7. Okay. So I know that I have these values here, and I can, the actual coordinate would be 1, 0 and 7, 0. I can put those on my curve now. If I want, I can graph them. So we have 1, 0, and we have 7, 0. All right. Now we got to keep going. It also asks us to find the vertex. Well, we did this on the previous page. So to find the vertex, we have to find the midpoint. So our goal is to find the x value of our vertex. So x is going to be equal to our r plus our s divided by 2. Well, pardon me. So r is 1. Our s is 7, so plus 7 divided by 2. That's 1 plus 7 is 8 divided by 2. That's going to give us 4. So we have an x is equal to 4, but we need the y component as well. So to do that, we have to sub x equals 4 into the relation, right? Into the relation. Actually, I guess at this point, into the equation. This is called an equation now. All right. No, it's not. We're still doing the relation. I apologize for that. We're not at the equation portion yet. We'll get to that on the next lesson. Go back. There we go. Stop clicking. My computer's lagging on me. All right. Set sub x equals 4 into the relation. So we have y is equal to our entire relation, which is you can do the factored form is probably the easiest way here. So we have x, which is 4, minus 1 times 4 minus 7. So that's the same thing as saying 4 minus 1, that's 3, multiplied by 4 minus 7, that's negative 3. That tells me that y is equal to negative 9. So our vertex is located at 4, negative 9. So we go to 4 and all the way down here to negative 9, way down in here. It doesn't actually ask us for anything else. It just asks us for the x-intercepts and the vertex and to graph it. So now we just got to draw our line. All right, I've done worse. Label y is equal to x squared minus 8x plus 7. Okay, I'm going to fix that minus. It looks like a plus. There we go. Y is equal to x squared minus 8x plus 7. Don't forget your axes, x and y. Okay, that's it for that question. So let's do it again. Now with a slightly more complicated relation this time. Y is equal to negative 2x squared plus 4x plus 6. First step we always do when factoring is take out the greatest common factor. In this case, we have a greatest common factor of negative 2. Why am I doing negative 2? because I want to make sure that I want to try and make it a simple trinomial. So by dividing by -2, that means my a term is going to be a 1. That's good news. So y is equal to -2. Now that means this just becomes x squared. The 4x, though, that's 4 divided by -2 is -2. So we have -2x in here. Okay? And 6 divided by -2 is -3. So now we got to factor the internal term here. So we need to find, this is a simple trinomial. So two numbers that add to 2 and multiply to 3. Well, that's pretty easy. 1 and 3 will work out here. So we have 1 and 3. Now what are the signs? We see that this is a negative. That tells me that they're opposite signs. And this negative tells me the biggest number is going to be the matching value. So the biggest number is going to be the negative in this case. So we have 1 and -3. We rate it again. We leave the 2 all alone. And we're going to have x plus 1 and x minus 3. Okay. So that's the first step. We've got it into the relation. Now we need to solve for the x-intercept. So we're going to set it equal to 0. So 0 is equal to 2 times x plus 1 times x minus 3. And now I need to solve for each of the x-intercepts. So I just need to set the factors equal to 0. So I have x plus 1 is equal to 0, which is going to be x is equal to -1. And over here I have x minus 3 is equal to 0, which is just going to be x is equal to 3. So the points we have are -1, 0, and 3, 0. Yay. But we need to find the vertex. So the first thing we need to do is find that axis of symmetry. So, same as we always do. For the axis of symmetry, we need to say x is equal to r plus s divided by 2. Okay. What is r? R is -1. What is s? It's 3. We're going to divide that by 2. -1 plus 3, that's 2. 2 divided by 2 is just 1. Okay, so we have the x component of our axis of symmetry, which is just a 1. But now we need the y component. I guess I'll box our 1 here. We need our y component, which means we're going to substitute it back into our quadratic relation. So sub x is equal to 1. Alrighty, so we have, where is it? There, down here. That should be a -2. There we go. So y is equal to -2 times our x, which is 1, 1 plus 1 times 1 minus 3. So that's -2 times 1 plus 1 is 2, and 1 minus 3 is -2. So we have -2 times 2, that's -4. -4 times -2, that's just equal to exactly 8. So therefore, our vertex is located at an x of 1 and a y of 8. And now we need to graph it in. So 1, 8, okay. Now our x-intercepts are -1, 0, and 3, 0. Right there. And now we just connect the dots. Don't forget your arrows. Label your axes and label your expression, your relation. Y is equal to -2x squared plus 4x plus 6. There we go. One last piece. Sometimes we don't have an equation. Sometimes we start with the graph itself. So write a relation in factored form to represent the parabola shown. Remember what we need for factored form. We need an a, we need an r, and we need an s. That's what we need for factored form. So r and s are the most obvious ones. We need to find those x-intercepts. And we can see that there's one right here. That's at location -2, 0. And we see we have another one over here. This one is at 4, 0. Okay. So that means our r is -2 and our s is 4. But what about our a? Remember, it's always the exact same thing to solve for your unknown a value. Substitute your r and your s into our factored form equation for what we have. So y is equal to a times x minus r. So minus negative 2 is the same as plus 2. Okay. And x minus s. Okay. So this is where we're at. We need to solve for a. That means that we need an x and a y. What x and y? Any point on the curve that is not one of the coordinates that we've already done. So we used both the x-intercepts, so we have to choose a different point. And we can see down here it told us that the vertex is located at 1, negative 9. So we're going to sub in 1, negative 9, and that is to find the goal of find a. That's the idea anyway. So y is negative 9, equals a, which is what we're looking for. My a's and my 9's look way too close. I guess once it updated there, it's fine. Now we have x. Well, x is a 1. 1 plus 2. And then 1 minus 4. Now just do the math. So leave the negative 9 alone for a second. Leave the a alone for a second. And now we have 1 plus 2 is 3 times 1 minus 4. That's negative 3. Okay, so we have negative 9 equals 3 times negative 3. That's negative 9. A. Oh, so we got to divide both sides by negative 9. Well, negative 9 divided by negative 9 is just 1. So our answer is a is equal to 1. So now we have all three values. We simply need to write it out. Therefore, y is equal to our a term, which is just 1, so we don't need to write anything in there. And then x minus r. So x minus negative 2, that's x plus 2. We already have it written over here, but and then x minus 4. And that's it. Those are all the basic skills you need for the rest of the unit in terms of having a good foundation. Going forward, we're going to start applying these things right away. See you next time.